The same motivations that have fed the explosion of big data, NoSQL, and Hadoop-type technologies spurred interest across the relational data community as well. They wanted to begin finding ways to deal with the same problems that those previously mentioned technologies were trying to address. Data was coming from everywhere, storing and analyzing it becoming a very large challenge for companies of all sizes. Larger and larger sets were pushing CPU and storage limits. At the same time, the relational community didn't really want to abandon everything that makes relational data so valuable. Despite what you may have heard, relational isn't going anywhere. In fact, everything old will be soon new again. Don't even get me started. Anyway, out of this came many high-end appliance-type solutions, such as Parallel Data Warehouse, or PDW in the SQL Server world, other offerings such as Teradata, Netezza, and others. Now, while offering promise in the realm of parallel and scale-out processing, these appliances were still kind of out of reach for most of us, translation being very expensive. Paracel, a small Silicon Valley company that had begun building their own approach to massively parallel processing and data warehousing, had an approach that was based on their own fork of the open source and very popular RDBMS engine Postgres. This approach used scale-out commodity hardware, kind of like Hadoop, but was still based on a relational data model, like other massively parallel process data warehouse appliances. MPP without the cost of a dedicated appliance. Eventually, this attracted the attention of Amazon, one of the biggest names in cloud computing platforms, who of course saw the benefit of both a scale-out infrastructure on commodity hardware, knew the requirements of big data, and recognized the convenience of column-oriented relational databases. Amazon, already offering NoSQL platforms as well as relational data platforms, added to this offering by investing in Paracel and eventually building what is now Amazon Redshift on top of those technologies that they had licensed. As previously mentioned, this was all originally forked from Postgres, version 8.0.2 to be exact, but has been heavily modified since then. As you'll see throughout this course, the similarities in SQL language are still there, but it would be wrong to assume that anything Postgres, especially later versions, can do is automatically supported by Redshift. It's interesting to note that they share a background, but Amazon Redshift is very much its own technology now. By the way, a redshift in the world of physics is when light or electromagnetic radiation has its wavelength increased. So pretty cool name choice, Amazon. To summarize then, what Amazon Redshift accomplished that appliances hadn't is the missing ingredient of leveraging commodity scale-out hardware, with the added elasticity of the cloud as a supporting infrastructure. And as you'll see as we move along, this really gives you both scale-out and flexibility at a much reduced price. And honestly, the performance for OLAP-type loads is pretty impressive. Alright, let's hop into this and learn about Redshift clusters, nodes, and node slices,